Question number 3 says a man is 6 feet tall, is walking at a rate of 3 feet per second towards a street light 18 feet high. And at what rate is the length of his shadow changing? So we want to find in this diagram, so I have the distance from the lamppost is x and the shadow length is s. We've been told that dx by dt is negative 3 feet per second because he's walking towards the street light, so he's making that length shorter. And we want to find the rate at which the shadow is changing, or ds by dt. So we need to connect the s and x together in a equation or a relationship. In this case, this is a similar triangle relationship. So what I'm going to do is I'm going to set up a similar triangle relationship here. So I know that the triangle made with the 6 feet and the triangle made with the 18 feet is the same shape. So we're going to make a ratio here. So we're going to say that x plus s, the horizontal length, divided by the vertical length 18 is equal to the horizontal length, which is of the smaller triangle, which is just s, divided by the vertical length, which is 6. And now we have a relationship between x and s, and we can generate our ds by dt and our dx by dt. So I'm just going to simplify this expression here. So I'm going to go x plus s and multiply both sides by 18. So I end up with 3s. And so I get x is equal to 2s. And then I'm going to differentiate this. Dx by dt is equal to 2 times ds by dt. Okay, we're told that dx by dt was negative 3 feet per second. I'm just going to highlight that dx by dt. And we're looking for ds by dt. Okay, so we're given the dx by dt was negative 3 feet per second. And that's going to be equal to the ds by dt here. I'm just going to highlight that in the right color. So I'm solving for ds by dt. And I'm going to divide both sides by 2. So my ds by dt, is equal to negative 1.5 feet per second. Okay, so that's part A. For part B, it asks us for how fast is the tip of the shadow changing. So if we take a look at this diagram, the tip of the shadow is this point right here. And basically it's going to move towards the lamppost with the rate as a shadow. So it's going to move with the shadow. It's also going to move with the x. So the rate at which the tip of the shadow is changing is going to be just the sum. We're just going to add those two rates together. So the tip, this is of the tip of the shadow, is just going to be the rate of x, so 3 feet per second, and we're going to add that to the rate of the shadow, so negative 1.5 feet per second. Okay, so the tip is going to be moving at negative 4.5 feet per second.